All right, so before we get started, before you get started with the Chapter 1, Section 3 lesson, I want to kind of give you guys some visuals about what we're going to be talking about. There are going to be 4 different things we're going to be talking about. And the first thing that we're going to be looking at is regular old continuous functions. Continuous functions is what you normally see. They are functions that you don't need to pick up your pencil for in order to keep going. So a couple examples that we may see is we've got like a linear. We may see like a sine or a cosine, a quadratic, a cubic, things like that. Most of the things we look at are continuous. However, especially when looking at piecewise functions or other different types of functions, mainly looking at graphs and rational functions, we may not get continuous functions. We may get forms of discontinuous functions. And there are 3 different types of discontinuous functions. I'm writing this shorthand because when you get into the notes, you will see the full form. I just want you guys to think about this. You don't necessarily need to write it down. You can if you want it quick and easy. So the first type of discontinuous function, I want to look at if I had, let's just say a line. I had a line and I wanted to take a hole punch through my line. So I'm going to pick anywhere on my line and I'm going to hole punch it. And that really would create like this open circle. Think a literal hole punch, okay? I have now removed a piece and it is now somewhere else. You could say it's now down here or whatever, okay? When I take the hole and I hole punch it, I have now created a removable discontinuity. And we typically see that in rational functions. We may not see this piece, we may just see the whole. If, say, we're looking at x plus 2 over x plus 2, x minus 2, and you're given a rational function, and you obviously want to simplify it, and those 2 cancel out, and it makes a whole. So the act of canceling a numerator and denominator creates that whole. So we could say, in our equation, that whole would be equivalent to being discontinuous at x equals -2. Our graph is discontinuous. Okay, that's one way. Now, another way we've got is more like a staircase, if you imagine. Let's say I've got this, and it goes to here. This, and it goes to here. This, it goes to here. If you think climbing a staircase. If you're climbing a staircase, and remember when you were little, you used to like try to keep your legs together and jump from piece to piece. As the act of moving along your graph, you're having to go and you're jumping up. And you go across and you jump up and you go across and so on and so forth. This, go figure, is called jump discontinuity. Now we also, for instance, let's see, a piecewise. You guys have been looking at piecewise the last couple lessons. Say I've got, my parabola to here, and then I've got the line over here, and it goes out. Even just that teeny little 2-parter, I have to pick up my pencil and jump across to a different piece. So your examples are piecewise. A step function is actually a piecewise as well. Now, our third and final form of discontinuity is where we see in a graph, let's just draw some basic axes, and I have a basic rational function. Call that at 1. Okay, so I have this rational function, and it has this asymptote right here. That is an infinite line that your graph cannot touch, we could say this basic function is 1 over x minus 1. That's what that function is that I just graphed if that asymptote is at 1. If we have a rational function like this where we've got an asymptote, the asymptote goes on with the arrows and it goes on to infinity. Therefore, this is infinite discontinuity. And we could say that this function is discontinuous at x equals 1. It's infinitely discontinuous at x equals 1. Okay, so those are your 4 types that you're going to be looking at. Hopefully this gives you a better visual and auditory explanation than just looking at those images on the next coming up slides.